Hello students, welcome back to Future Foundation. Students, today's class of vectors, we will start with questions and then we will come to the topic vector equation. So let's begin. Question is box of ABC into box of A dash B dash C dash is equal to question mark. Here A dash B dash C dash are the reciprocal vectors of A, B and C respectively, right? So we have talked about reciprocal vectors in last class. So for solving we can place A dash B dash C dash in terms of ABC. So now what will second box become if I replace A dash by B cross C upon box ABC. Similarly this B dash is C cross A on box ABC and C dash is A cross B by box ABC. Now using properties of determinant in second box we will get 1 by box ABC whole cube from second box and this box ABC as it is, right? And second box is B cross C, C cross A and A cross B. Okay, now again using the property or you can say trick, this second box will become box BCA whole square. Okay, and box ABC is nothing but box ABC. So numerator will become box ABC whole cube and in denominator box ABC whole cube is already given, is already present, you can say. So this will become 1, right? Now come to some remarks. Remark 1. I cap, J cap, K cap are their own reciprocal vectors. It is very easy to understand that if I am finding I cap dash, so I cap dash is nothing but box but J cross K upon box Ij, right? So J cross K is nothing but I cap and upon box Ijk is 1. So I dash is I, right? Similarly J dash is J and K dash is K. That's why I said I, J, K are their own reciprocal vectors. Second one, A plus B plus C dot A dash plus B dash plus C dash is 3. Okay, now why it is 3? You can understand by putting A dash B dash C dash in terms of ABC, right? So or you can direct multiply A dash plus AB dash and AB dash is 0 because AB dash is nothing but A dot C cross A and A dot C cross A is 0. So this will be 0 plus 0 plus 0 plus BB dash plus 0 plus 0 plus 0 plus CC dash and which is 1 plus 1 plus 1 3. Third one, A cross A plus B cross B plus C cross C is 0. Again, A dash is nothing but B cross C upon ABC, and A dot B cross C is A dot B cross C on box ABC plus B dot C cross A on box ABC plus C dot A cross B on box ABC, right? And you know very well, A dot B cross C plus B dot C cross A plus C dot A cross B is 0. Sorry, this is cross, not dot. My mistake. So A cross B cross C plus B cross C cross A plus C cross A cross B is 0. So answer is 0. We have seen this in last class. Okay. Okay, now fourth remark is C dash cross B dash plus B dash cross C dash plus C dash cross A dash is A plus B plus C upon box ABC, right? You can do this by yourself. It's your homework. Now next question is, let U6 minus 3 2 V 263 and W 3 2 minus 6. These are three vectors given. Option A, form a right-handed system, form a left-handed system. C, are linearly independent. And D, each is perpendicular to the plane of the other two, right? So now we have to give answer which one is correct. So right-handed system or left-handed system will be determined by the determinant of u, v and w. If value of determinant is positive, then system is right-handed system, and if value is negative, then system is left-handed system. So first of all, I will find determinant of u, v, w, which is determinant of 6 minus 3 2, right column wise, as column vectors are given 2 6 3 3 2 minus 6. Okay. So 6 times minus 36 minus 6 minus 2 times 18 minus 4 plus 3 times minus 9 minus 12. Obviously this is negative, so you can say u, v, w form a left-handed system. Okay, let's come to next options. Maybe more than one option is correct, are correct. So for C and D, if I see option D, which is each is perpendicular to the plane of the other two. So for perpendicularity, we usually see dot product. So also u dot v. U dot v is 6 to the 12 minus 6 to the 18 plus 3 to the 6, which is 0. It means u is perpendicular to v, right? V dot w 2 3 is 6 plus 6 to the 12 minus 6 3 is 18, which is 0. So this is here v is perpendicular to w and u dot w means 6 is 18 minus 6 minus 12, which is again 0. So here from here we can say u is perpendicular to w. So each is perpendicular to the plane of other two, means option D is correct. And if these three vectors are non-coplanar and also they are mutually perpendicular to each other, it implies that they are non-collinear as well. It means they are linearly independent. So option C is also correct. And option B is also correct, which we have already seen. Now let's come to next question. Find angle between planes of a regular tetrahedron. See, regular tetrahedron is a pyramid having four triangular faces, right? This thing we already know. And each triangular face is an equilateral triangle, right? So I am drawing this tetrahedron. Here ABCD is a tetrahedron having base BCD, right? So we have to find the angle between any two planes or any two faces. So I'm interested in finding the angle between plane ABC and plane ADC, right? So here a normal vector perpendicular to plane ADC is say n1 vector, and a plane and a vector, normal vector perpendicular to the plane ABC is say n2 vector, right? So cos theta, where theta is the angle between ABC and ADC. So cos theta may be defined as n1 dot n2 upon mod of n1 to mod of n2, right? And n1 is a perpendicular vector to the plane ADC, right? Also, I am finding position vectors of the vertices as null vector, p vector, c vector, and t vector, right? Now, n1 vector is c vector cross t vector, right? And n2 vector is e vector, sorry, p vector cross c vector. Okay, now cos theta will become p cross c dot p cross c dot c cross t on mod of B cross C into mod of C cross D, right? Also this tetrahedron is a regular tetrahedron, so edge uh, each edge is equal to k, we are assuming. Also let mod B is equal to mod C is equal to mod D is equal to say k, right? So tetrahedron is regular, and we have already defined that triangle is face is triangular, or face is an equilateral triangular, face is an equilateral triangle, so angle will be 60 degree with any between any two edges. Now as we are seeing, cos theta is having numerator as scalar product of four vectors, so we can find B cross C dot C cross D as B dot C cross D as B dot C dot D times C minus C dot C times D, okay, which is B dot C into C dot D minus B dot D into C dot C, right? So I can place this thing here, and you can also calculate this B dot C. B dot C is B C cos theta. Theta is the angle between B vector and C vector. B vector, C vector are the edges of a regular tetrahedron or side of any face. So cos pi by 3 minus into mod C mod D cos pi by 3 minus mod B mod D cos pi by 3 into mod C square, right, upon this is mod B cross C, which is mod B mod C sine pi by 3 and mod C mod D sine pi by 3, and we are finding acute angle, so we are taking mod, right? So mod C mod, this is k square into 1 by 2 into k square into 1 by 2 minus k square into 1 by 2 into k square whole mod on square into root 3 by 2 to k square into root 3 by 2. So k square, k to the power 4, k to the power 4 cancel out from numerator and denominator, and mod of 1 by 4 minus 1 by 2 upon 3 by 4, and this will be 1 by 4 upon 3 by 4, which is 1 by 3. So cos theta is 1 by 3 implies theta is cos inverse 1 by 3, which is required angle. So angle between any two faces of a regular tetrahedron is cos inverse 1 by 3. Now let us come to next topic, which is vector equation. So write down the heading vector equation. So in this we will write if dot product cross product both are given, always to a cross product, an appropriate quantity given cross product, and use dot product, right? What I'm saying, let us take a question to understand this better. Question is, if a vector is I cap plus j cap plus k cap, b vector is I minus 2j plus k, and vector c is such that a dot c is equal to 2 and a cross c is equal to b vector, then c vector is equal to question mark. So vector equation is a question having dot product and cross product both in this statement. So in this question also there is dot product, and cross product, both are given, right? So if we are understanding here that question is of vector equation, then we have to always take a cross product with an appropriate quantity with given cross product, right? With given cross product, and then we will use dot product, right? So here a dot c is given, right? A dot c is given, and we have to take a cross with this cross. So what do you think, which is an appropriate quantity in this case? We want to use this dot, right? So how we can make a dot c with this, right? With this, how we can make a dot c? Please use your mind. Yeah, we can, if we take a vector and with that vector we take cross with a cross c, then a dot c will be formed. So here a cross c is equal to b vector. Now I am taking cross product with a vector and a cross c vector, right? That appropriate quantity is a vector. So now a cross c is nothing but a dot c times a minus a dot a times c is equal to a cross b. and E cross B is I J, determinant of I J K 1 1 1 1 minus 2 1, right? So A dot C is nothing but 2. So 2 A vector. A vector is 1 1 1 1 1 1 minus A dot A. A dot A is mod of A square, and mod of A square is nothing but root 3 square times C vector is equal to I times 1 plus 2 minus J times 1 minus 1 plus K times minus 2 minus 1. So this is 2I cap plus 2J cap plus 2K cap minus 3I cap and plus ka 3K cap is equal to 3C vector, right? So C vector is nothing but minus I cap plus 2J cap plus 5K cap on 3, right? So this is required C vector. Okay, let us take another question. Question is, let E vector is J minus K, C vector is I minus J minus K, and P vector is satisfying A cross P plus C is equal to 0 and A dot P is equal to 3. Find P vector, right? So again, here you can see dot is given and cross is given. So again, I will use the concept of vector equation. What we will do, we will take cross product with an appropriate quantity so that A dot B can be used, right? So I will take cross product with given cross product, right? So this is A cross B is equal to minus C. So how we can make A dot B? By taking cross with E vector. So E cross B is equal to minus E cross C. So E dot P times E minus E dot E times P is equal to minus A cross C, because A is given, C is given, so I can find A cross C as well. So determinant of IJK 0 1 minus 1 1 minus 1 minus 1. Okay, so A dot B is 3. 3 E vector is 0 1 minus 1 minus mod A square, which is 2P factor, is equal to minus I times minus 1 minus 1 minus J times 0 plus 1 plus K times 0 minus 1. So this will be 3J cap minus 3K cap minus 2I cap minus J cap minus K cap is equal to 2B vector, right? So from here B vector is minus 2I cap plus 2J cap minus 4K cap by 2, or B vector is minus I cap plus J cap minus 2K cap. Let's move to next question. Question is, find vector x satisfying vector dot x vector is equal to C and A cross x is equal to B vector, right? So we have to find this x vector. I will use concept of vector equation. So as E vector cross x vector is equal to B vector, and I have to make A dot x. So how can I make A dot x? By using cross product with A vector and A cross x vector. I can make A dot x, right? So this will be like this, and it will become A dot x times A minus E dot A times x is equal to A cross B. So A cross B will remain as it is, and A dot x is C. So x vector will become A dot, that is CA vector, CA vector minus E cross B on mod of E vector square. This is required factor x, right? Now let's move to next question. If px vector plus x cross A is equal to B vector, then prove that x vector is equal to p square B vector plus B dot A times A vector plus B times A cross B upon B times B square plus A square. And now this thing we have to prove. So you can see this question is little bit different from other one we have discussed. So but thing first thing we should be but first thing which should come in our mind is that here cross and dot both are present. So again this question is of vector equation. We should think in this direction, right? So for this also this cross vector or cross product is given. So by using this I'm writing x cross A vector is equal to P vector minus Px vector. Okay, right? This thing I can write. Say this is what. Now again Px vector plus x cross A vector is equal to P vector. Now I have to make this A cross B. Okay, this A cross B I have to make. How can I make this A cross B? By taking cross product with A vector. I can make this A cross B. So A cross A vector cross Px vector plus A cross x vector cross A vector is equal to A cross B vector, right? Now this can be written as like this also. P times A cross x, because P is a scalar. This can be taken outside, plus A dot A times x vector minus A dot x times A vector is equal to A cross B vector, right? Now this A cross x is nothing but, from 1 we can say this is Px vector minus P vector, because in 1 it is written x cross A, but we need to write A cross x, so minus will be taken out, plus this A dot A is nothing but mod A square times x vector minus A dot x. Okay, so we need to find this A dot x, this A dot x also. So from given equation, if I take dot product with A, so this will be A dot px plus A dot x cross A is equal to A dot b. Now this A dot x cross A will be 0 because x cross A and A vector are perpendicular. So P times A dot x is equal to A dot b, or A dot x will become A dot b by P, right? So this is A dot b by P times A vector is equal to A cross B vector, right? In next step, this will be P square x minus PB vector plus simply this is A square x vector minus A dot B times A vector by P vector is equal to A cross B. Okay, now take all terms having x vector to one side and remaining to other side. So this will be minus P square B minus A dot P times A vector minus P times A cross P by P is equal to minus P square x minus A square x. Okay, or you can say x vector. This is x vector. So this x vector will be P square P plus P square B vector plus A dot P times A vector plus P times A cross P vector on P times P square plus A square is x required vector, and this thing we needed to prove, right? It's proved. So for today's class, student, this was all about. Let's meet in next class. Till then, bye bye and take care.